Hello everyone. Thank you for being here. Today, I'm going to talk about one of the most, let's say, important promises that Mojo programming language, let's say, mentions, and it is the speed actually. And they said like we are going to be like many times faster than normal Python. And today I'm going to, let's say, somehow with let's say one scenario, one small code, test it and then see if it's faster or it is not, or why it is faster. Is it because it is more optimized, or maybe it is only because it's some kind of compiled based programming language rather than interpreted based programming language. Once again, just as a summary, many of you know that a language like Python, Ruby, or I don't know, things like that, they are some kind of interpreted based programming language, means uh, it is translated to the machine language at the time of the execution by the interpreter. That's why you have to have Python installed on your systems when you are coding in Python. When you put it somewhere else, the interpreter of the Python should be installed there. And but when for the compiled based programs like C, C++, Go, and Mojo, you don't need for an interpreter to be there because it's, let's say, at the time of the compile, it's translated to the computer native machine language. So anyhow, you already, if you are not familiar with VS Code and how to, let's say, run Mojo codes and how to do the Mojo coding, I already explained it briefly in one of the videos. You can find it in the channel, and it's just somehow like getting started with Mojo. And I'm just starting to, let's say, I'm assuming that you all know this part, and I'm going to talk about, let's say, just write a code in Mojo and then compare it with Python. So let's say for this purpose, I am going to, let's say, write a code that many of you know it, like very classical example, just to calculate the prime numbers before a certain number. For example, all prime numbers before 1000, all prime numbers before 1 million, or something like this. It is some classical programming, let's say, examples. And usually it takes a time, specifically when you put a, let's say, big number, and we are going to put it in a test with Python, with Mojo, and maybe some other stuff. So let's say I would lay Mojo prime, or let's say prime Mojo, because I can find them easier. Prime Mojo dot Mojo. Okay, so uh, with any, let's say, type of methods, of course you can, let's say, calculate and find the prime number in many different methods and style, but we are just you can just feel free to change it or whatever you want. So I'm going to start as a reminder. We all know that in Mojo, everything should be part of a function. It's not like Python that you can have, for example, print here, right? It's wrong in Mojo. So that's why at first I'm going to write my main function. And in Mojo, you put def or fn. I explained it in the previous video, but here I'm going to write my main function. This is the first function that runs in the Mojo. And so let's say I'm going to calculate all numbers before, let's say, 5 million, and then calculate how long it took, so I can compare it with Python and everything. So let's choose a number. So I will put let, because my number is immutable. I don't want to change it and increase it. So let's say let num, and it is an int, And remember, this I should be capital in Mojo. Equal to 5 million. Okay, so far so good. And now I'm going to write a function like find, I don't know, primes before. I always like to put very descriptive names, so it always helped me. So that's why I'm going to write such a function. So I just defined it. Let's define this function here. So let me put it, copy paste it. Okay, I want to now define this function. So basically it's going to get a number, right? So I would put like n, which is in int. Okay, and let's oh, fn, forgot to put it. Fn finds prime numbers, and I would say for I in, as you can see, we can have the, let's say, luxury of using all the Python syntaxes. So range 2 to, let's say, this n. And now I'm going to check if this is prime or not. And if is prime, print it. So I will write if is prime, this I mean. If it's prime, then print it. Print I. So let's keep it simple. So because today our course, I mean our let's say experience is not about coding in Mojo, it's more about testing its speed. So I put a function here, right? Is prime. Let's define it for ourselves. So fn is prime. So again, it gets a number and it returns, either you can see, true or false, right? Because here I said if is prime, which means here it should be bool, means boolean. So now I would say, as I said, like here I'm going to use some kind of trial division method, and let's say somehow a kind of optimized version, but you can just define finding prime number based on your choice. I'm just using this style. So I would say first, if n is, let's say, smaller or equal than 1, then return false, for example. Means it's not prime. Then false. Now again, if n is small and equal than 3, I mean 2 and 3, then again I would return true. It's like I'm handling the first basic, let's say, exceptions. Then I'm going to write the general rule that captures the rest. Then it's yes, it's a prime. Then I would say all the multiplies of 2 and 3 now. If n remainder to 2 is equal to 2 is equal to 0, means it is divisible to 2, or for 3 as well, and remainder to the 3 is equal to 0, then of course it's not prime then if it's divisible to 2 and 3. And now I will start from number 5, okay? And from number 5, we can prove that, let's say, all the prime numbers there, it could be like 6k plus 1 in form of 6k plus 1, which means I'm going to just, let's say, go up with 6 step each time. So yeah, let's do it. So first I will define, because it's I'm going to have a counter, means I'm going to define it as a var, not as a let, right? Because it's mutable. So it is int and equal to 5. So from 5 I'm going to start, and while I multiply to I, basically I'm just going to go until the square root of the, to the square of the n, which I can just simply write it I multiply to I is smaller than n, right? And because all if it's enough for us to go to just to the square of the n. And if what I said, feel free to change whatever you want. And I if n equal remainder to the I is equal to 0, or and remainder to I plus 2, so I plus 2 again is equal to 0, then return false, it is not prime. Okay, and now I'm going to add it for 6th step and return true. Why true? It means if we go through this and it doesn't this if doesn't triggers, means, and going like each time 6 step means it was a prime number, else it would be triggered here. So this is my, let's say, is prime function. And so I have it. So I also want to, let's say, calculate the time that this function runs. So for this I need to import something that I can get time from. So from time, import now, and here I would say, for example, let start, just defining a variable, start time, and it is, let's say, int, in form of int, and is equal to now. Sorry. So, and also here start time and then end time. So let end time int equal to now. So now I will have another variable which I'm going to, let's say, elapsed time, which is int, and equal to, of course, end time minus start time. So this gives me, let's say, the time in nanoseconds, right? And if I want to, let's say, convert it to this, to the, let's say, seconds to be more understandable, I need just to divide it to the, let's say, I think 1 with 9 zeros. So let's elapse time in seconds, in, let's say, seconds, and it should be float, right? In Mojo you can have float of 32 or 46, but I think for our case 32 is enough. So it's equal to elapsed time divided with 1. We have 1 2 3 4 5 6 7 8 9, and something like this. Let me count it again. 1 2 3 4 5 6 7 8 9. Okay, that should be okay. And now print it, elapsed time in seconds. So we have our Mojo code. Okay, and now let's build it. So I would write Mojo build -o for just choosing a name. So I would, let's say, prime Mojo, prime Mojo, and what is my source file is prime underline this. Okay, now let's run it. Prime Mojo dot okay, no, sorry, so the name is prime Mojo. I just wanted to run the source. So as you can see, it is ran. So 5 seconds or something. Sometimes it's, when you run it for the second time, it would be faster or slower depending on the computer and the situation. I just run it just to know, make sure like approximately. So I would say here I had, let's say for Mojo, I had this amount of time, like 5.6. As I said, it could be different if I run it, for example, for the third time, but at least it gives us like roughly some time of how long it took. So 5.1 here, see? So just let it be, but it can be up and down a little bit. So now I want to write this same code, but in Python, okay? So if I want to write it in Python, so let's say prime python.py, like this. So now I'm going to write the same structure, same everything, but in Python. You know, in Python, if you want to write a main function, you just put like if something like this, name equal to main, something like this. So I would be a bit faster just because you already know everything. So number would be 5 million. Yeah. And then I would need some kind of a start time. So like start time. So for getting time, I need to import time function in Python, import time. So it would be time.time like this. And I need some kind of end time, and time is equal to time, the time, like this. And here let's define the same name, find, for example, primes before, for example, n, and I have this no here. And now let's define it here, def. Okay, and I'm going to get an n, and for I in range, it's similar, and like this. And I would say if is prime, I'm just keeping the same logic, and then return, no, just print it, print I. So this is same logic. Now let's define this is prime. So def is prime, it gets a n. And just one thing, even in Python you can define, for example, the return of your code is boolean, right? But the difference is it's just not mandatory. So Python already had it, for those of you who don't know what. But simply in Mojo you have to, if you define your code with fn, define your function. So let's keep the same logic. If n is smaller or equal to 1, then return false, and oops, and then if n is equal to smaller or equal to 3, return true, and then if n remainder to 2 is equal to 0, or n remainder to 3 is equal to 0, then return false. Of course, if it's divisible to 2 and 3, it's not prime, then same logic. Now I equal to 5, and while I multiply to I and smaller than n, smaller equal than n, then I would say if n remainder to I is equal to 0, or if n remainder to I plus 2 is equal to 0, then return false, right? And of course now add I for 6 steps, 6, and then return true. It means if none of these triggered, then you are a prime number. Okay, now we have everything here. Now let's say calculate the elapsed time. So elapsed time is equal to end time minus 2 start time. And we don't have to convert anything, as in this function we already get the time in seconds. So it is already seconds. So then print, and print what? Elapsed time. Okay. Now if I run the Python prime Python pi, right? Now let's see how long it takes. Already way longer, right? So as you can see, this is the difference between an interpreted programming language. You have an extra layer between the operating system and your code, which is, let's say, Python interpreter. That's why it takes so long rather than just a program that has been compiled. For example, 35 seconds. Even if I, let's say, rerun it again, it could be something around, but until now, let's just say Python code. So yeah, and that's why, the speed is not always in terms of, let's say, we have two types of a speed. One speed is execution speed, and one speed is, let's say, development speed. Of course, in Python you can develop your code fast, but the code itself might not be really fast. So yeah, that's 34. Let's see. So 34, you can see the huge differences. You see, very, very, let's say, huge differences. So, but does it mean that Python code is not, let's say, optimized, or is it because we have an extra layer as an interpreter? I mean, when I run the Mojo code, I just executed the Mojo code like this. But when I use Python, I I write Python like this. It means Python is running my code, not the code is able to run by itself. So what if we could compile Python? Hmm? Many of you might, for example, I don't know, some people says, oh, you cannot make an executable of Python. And you might, for example, seen some project like PyInstaller. But PyInstaller is not actually compiling the code into the machine language, but it just attach a small Python to your code, and every time extract the Python and code and run it. But do we have any way to compile our Python code? Well, one of the ways, I said it even in the previous, let's say, a video about the Mojo, it's called CODON. You can find it in the GitHub, and also you can, let's say, install it like this if you have Linux, or just like a virtual Linux, same like I do. And when you run it, and of course after you install it, you might just take care of path, put it in the right path, set the path of your Linux and so on. And then they say that, I mean, if you even see this, they somehow translate the Python as if it was written in C. I mean, it's being really compiled to the machine language. Okay, you can use it. It's still, let's say, in earlier stages. It's less than a year, if I'm not mistaken, that it is, let's say, uh, released. And of course, it's going to grow and be better. But with this, you can simply compile your code for real into machine code. So let's see if we do it in our code. Would it help or no? I already installed it, the Codon, and you can use Codon run your code or Codon build to compile it and then run it. Since I did the same for the Mojo, I'm going to do it like this. So codon build dash o. So let's say codon codon prime, for example. It's still Python, but just the name. And what is the source of file? Prime underline python.py. So let's see if we can compile it. Okay, I compiled it, right? Now I have a codon prime code. Let's see now how fast this compiled code will run. It is the same Python code, only compiled to the machine language. So it was 34 or something, right? Before 4 seconds. 4 seconds. Once again. See? 4 seconds. So you can see when you run Python on Codon, I mean, not run Python on Codon, compiled Python with Codon. Let's say, for example, 4.0 or something. Okay, so let me once again run the Mojo one, just to don't have the time delay. So as you can see, this time 4.7. So as you can see, for example, if I just put it 4.7 something, just for say, you can see that even Python itself, if you just compile it with Codon, it can be as fast as Mojo, if not faster. So it's pretty cool, let's say, project that solves the speed of the Python. But of course, this project is at the earliest stages. It might not support, let's say, all the libraries. It might not support when you have, for example, I don't know, TensorFlow. You might have things like this, but gradually it probably get better. Even they say they are supporting even GPUs for those specifically that do the training on GPU. But as I said, it's still at the earliest stages, and maybe it's and one thing to mention, this is for one cases. We are just testing the, let's say, arithmetic or calculation part of this aspect between these two codes. For example, when you are doing, I don't know, optimization problem, visualization problem, simulation problem, and so on, the output and outcome would be different. But just we have roughly some idea of how fast it is or no. So for the sake for the last part, let's do something else. Just because we are nerds, and we can use, for example, let's use some very type of, let's say, compiler based languages, and let's see how fast or slow this code, the same code, would be on those programming languages. For example, we can have C, write it in C, or write it in Go. Both would be fine. And which one we should be? Oh, let's flip a coin, right? So, and flip a coin. If it was head, we will go for coin, for Go. So head for Go. Okay, head Go, right? So let's write it in Go and see how it would be. So I love both languages, but so prime go dot go. Okay, so we will just keep the same logic, but just this time with the go, and let's see how fast or slow this would be. So in the Go, for example, in C, you know that you use, for example, int, void, or something like this. In Go, you define your functions with func keyboard. So func main, and open and let's say close it. So I have let's say some kind of I need some number. It was, if you remember, it was number. So I will just set my number to 5 million. When I assign it like this, it automatically understands it's, even though it's compiled based program, it automatically understands that it is, let's say, some kind of integer. So nothing, no problem will happen. So, and then I'm going to write my, let's say, finding prime numbers. So let's say find prime before n, and I'm going to send this number here, and of course semicolon here, it's needed. And so oh, I can even in Go, I think it's you can even put it, or you can, it's not necessary just like C programming language. So it's a long time we haven't coded in Go. Okay, so find before n. Now let's define another function. So find, this time find prime before. So let's keep this, keep the primes. It was the primes, and here I would put the primes before n, and I would get a, let's say, some kind of n which is int. And so for I, let's say, equal to 2. If you remember, we were using range, but here we are using 4, and I smaller than n, and I plus plus. Okay, and now we say if you remember, is prime, and I, okay, if we want to print in let's say Go programming language, we have to import some kind of library. So first, then let me things like package first, package, oops, package main, and then here I would import. So let me open, this is how you define your imports. So if you want to print something, it's just like stdio in C, it's called fmt. You define that you want, let's say, to you have some kind of library that lets you to print stuff. And then, or since we are going to calculate the time as well, I will already do this, so to make it like ready, my packages are already done. So now I have to print, right, if you remember. So since I want to print, I just put fmt that it was print ln I. Okay, so basically we do this. I'm going to print it, and now let's define this is prime. So func is prime. What it is getting, again, a number. So n would be int, and it's going to return a boolean for us. So it's bool. Do you remember in C we put it in the beginning? In Go, it's different language. Go is specifically good when you want to do, let's say, concurrent programming. It has some built-in keys called Go routine. You can search about it. So then I would say if n is smaller equal to 1, then return false. And then if n is smaller than or equal, smaller than or equal than 3, then again return true this time, because it would be 3 and 2. Then again, if n remainder to 2 equal to 0, or is like this with double pipe, and remainder to, let's say, 3 is equal to 0, then return. So it means basically if it's divisible 2 and 3, it is false. It's not prime number then. Okay. And now I will just set I equal to 5, the way we were doing just like before. Then for I, multiply to itself, because we are going to the square of the n. So let's say it would be smaller than n. So until then, um, so um, basically it's just like we are square rooting the n. See, it's like, this sign. So rather than putting sqrtn, I just multiply it, like make it to the power of 2. So then I would say if n remainder to I equal to 0, or the same logic that we had, and remainder to I plus 2 equal to 0. So if it was so, then means it is not prime. So return false, right? And then I go 6 steps, so like this, 6 steps ahead. And if none of them triggered, return true, means then you are some kind of prime number. So let me just double check it. I is smaller than 10, then it's false, then true, divisible by 2 and 3, it's false. False. Okay, should be good. And now let's go here and just calculate the time before and here. So I would just let start time is equal to, let's say, time dot now, right? So this is a start time. Okay, since it's not used, I'm going to use it. End time is equal to time dot now. By just writing in Go, once again, I just want to see if there is a, let's say, some kind of system level programming language like C or Go or Rust. Are they really faster? I mean, very faster. So let's see. So then elapsed time is equal to, so end time sub means like minus to the start time. So start time. So basically I'm just subtracting this to this, and now I'm just going to print it. So fmt dot print line elapsed time, sorry, elapsed time, to convert it in seconds, and I can just write seconds, or just don't need to do this. So that should be good, hopefully. So let me save it, Control S. Now I have Go installed already, so Go build dash O, for example, prime underline Go, and it is like prime go go.go. So let's compile it. So I compiled it, and now let's run it, prime go. So let's see how fast it is. 3.5, you see, it's faster. So 3.5 almost. So let's say go 3.5. So What we saw here that if you need really fast coding, we will go to something like Go, C, Rust, or something. But of course, these programming languages are not designed for the AI. And even Mojo isn't say, okay, I'm going to replace Go, C, and Rust and everything. It says I'm a faster and better way to, let's say, somehow implement AI codes, which usually are done in Python or Java. But yeah, as you can see, for the Mojo, we had pretty fast, let's say, speed. For Python, it was really slow in comparison to this. But when we compiled Python, actually, the very same code with the codon, it was as fast as Mojo, if not faster. So that was what I wanted to say. That not all the time we can say, let's say, Mojo is faster than Python because, yeah, they do some kind of magic, for example. No, sometimes the speed could be as a result of the nature of the code. If there is something compiled based, it is in most of the time, if not all the time, it is faster than interpreted type of programming language, because when it comes to the interpreted programming language, there is an extra layer between the code and the operating system. So that's it. Hope you like it, and hope to see you soon.